Education Hub. I am Akash, and today we are going to study about pure substances and Gibbs phase rule. Pure substance. A substance is said to be a pure substance if it is of homogeneous chemical composition throughout. It is not necessary that a pure substance have to be a single chemical element or a compound or a mixture of various chemical elements or compounds also qualifies as pure substance, but as long as the mixture is homogeneous. Let's understand this with some example. A container, let's say, filled with nitrogen. This container filled with nitrogen gas is example of pure substance. Next example, the container partially filled with water. Obviously, this container will have also some vapors. That means this container contains water in its liquid form and in its gaseous form also. Now, this is also a good example of pure substance. Next example, a container that filled with water and some kind of oil, mustard oil for example. Now this system, here we have impure substance. This mixture is not homogeneous mixture. That is, mixture of water and oil is a impure substance. Container filled with different gases or mixture of gases is also an example of impure substance. Impure substance. Here the phase is same, that is gaseous phase, but we have lot of different compounds. Now all the compounds or element will have different liquefaction temperature. That means they liquefied at some different temperature. That is why this is an example of impure substance. Now moving on further, let us understand about Gibbs phase rule. The Gibbs phase rule describes the possible number of degree of freedom in a closed system at equilibrium in terms of number of separate phases and the number of chemical constituents in this system. Now, the formula given by Gibbs is P plus F equals C plus N. In thermodynamics, we take N equals to 2. P plus F equals C plus 2. This N represent non-compositional variable. In thermodynamics, there are two non-compositional variables, that is pressure and temperature. So we take N to be 2. Here this P represents the phase, that is the phase can be liquid or gaseous or solid. Now the C represents chemical constituents. The C represents number of chemical constituents, and obviously this F will be the degrees of freedom which we need to calculate. Let's understand this with some example. Let's say we have a gaseous mixture of oxygen and nitrogen, and we need to find degree of freedom for this. Now here in this example, the number of chemical constituents are 2. We have 2 chemical constituents, that is oxygen and nitrogen. The phase in which they present is gaseous. Now from here we conclude that P is 1 and C is 2. If we put this value in formula, we get 1 plus F equals 2 plus 2. Now degrees of freedom for this condition we have is 3. Let's calculate for water and water vapor. Here we have chemical constituents is 1, that is water. So C here will be 1. But now this water is present in 2 phases, liquid and gas. Therefore here we will have P to be 2. Now according to formula, 2 plus F equals 1 plus 2, and P plus F equals C plus 2. Now here our degree of freedom is 1. Now moving further to next example, let's say we need to find F or degree of freedom for triple point of water. This triple point of water is that point where water exists in all 3 phases, that is solid, liquid and gaseous. The temperature at this triple point is 0.01 degree Celsius, or in Kelvin it is 273.16 Kelvin. The pressure at triple point is 0.61 kilopascals. Now for this, P plus F equals C plus N. Now at triple point, water exists in all 3 phases. So here value of P is 3. We need to find F. Chemical constituent is 1, that is water 1. plus n in thermodynamics is always 2. Now according to this, F degrees of freedom will be 0 for triple point of water.